Today we are starting 7-3. We're going to do this in 2 days. Today our focus is going to be on the double angle and half angle formulas. These are formulas that you will get on your quiz, okay, so you don't have to worry about memorizing them, but you do have to know how to use them. So all of these can be proved with the addition formulas that we did last week. These double angle formulas, which you can see it's the sign of 2x, it's double. Okay, the double angle formulas allow us to find values of the trig functions at 2x once we know the values at x. Okay, so when it says they're consequences of the addition formula, this is what that means. So do you guys remember last week how when we did those formulas, it was like the sign of s plus t? And then if you had the sign of s plus t, it was the sign of s. You don't have to write this down. I just want you to recall this with me. Sine of t plus the cosine of s times the sine of t. Do you guys remember that? Okay, so when we say that you can use these, if instead of s and t, if we use x plus x, right? X plus x is what? Yep. Let's look and see what happens. So this would be the sine of x times the cosine of x plus the sine of x times the cosine of x. These are the same thing. Okay, so this would be 2 sine of x cosine of x. And if you look here, okay, that is exactly what your formula is. So you can prove all of these formulas just by using your double angles. I wrote out the cosine one too. Like if you have the cosine of x plus x, you get the cosine of x squared minus the sine of x squared. Okay, it's not imperative that you know those. I just want you to know where they come from, how all the things we're doing are tied together. So for the sine, you have this one equation. Okay, the sine of 2x is equal to 2 sine of x cosine of x. For cosine, you have 3 equations. You can use any of those. Okay, those are all for the cosine. Maybe we should highlight them instead. So cosine, and then we have the tangent. Maybe it's a different color for that. Okay, and then we are going to find the double angles of all of those, but I want you to look at what you're plugging in. So you have the cosine of x and the sine of x, okay, the tangent of x, and then sometimes we are squaring them. Okay, and then I'm just gonna, I think this will be easier when you guys look back so you can see which is which. Okay, and I did type those in for you because look, we're gonna write them in ourselves, but I said, nope, let's do some highlighting today. So your tangent, okay, can be this, and then another thing that you can use for a tangent is the sine of 2x over the cosine of 2x. Okay, so we're gonna go over all of those today. All right, so we're gonna find the double angles from the given information. So there are 2 methods you can use. I'm gonna show you both methods on part A, and then I'm gonna let you choose when you're doing this on your own. Okay, so you can draw a triangle in the quadrant, and then you can use the Pythagorean theorem to solve for unknown sides. Okay, so you can draw a triangle in the correct quadrant, and we're going to use the Pythagorean theorem to solve for our unknown sides. Okay, the second thing is you could use an identity to solve. The nice thing about method 1 is that is always going to work. Okay, so method 1 is always going to work no matter what. And then sometimes the identities are a little bit harder. So you are given the sign is -3/5. Sign of x is -3/5. And it says x is in quadrant 3. Okay, so it's the x value, not the double angle, just the original. So if we're going to use the double angle formulas, before we do that, we're going to have to use the sine of x, the cosine of x, and the tangent of x, since we have to substitute those into our formulas. So to use the tangent double angle, we need the tangent of x. To use this, we either need the cosine or the sine. This one, we need the sine and the cosine. So we have to find those if we are going to use the double identities. Okay, so we're going to do method 1 first. Okay, so method 1 is the triangle method. Okay, and because this one always works, can you always use that? Yes, absolutely. Okay, the only reason you might want to use the other one is if you notice it right away. In some cases, it's quicker. Okay, so what we're going to do is we are going to draw a triangle in the correct quadrant. So if it's in quadrant 3, you always want one of the sides to be flush with that x-axis. And then this is going to be your angle of x. Okay, so in order to set this up, you are going to use what you remember about SOHCAHTOA. So the sine of x is -3/5. Okay, we know that that's given. We know that that's the opposite over the hypotenuse. So the opposite would be -3. Your hypotenuse is 5. The hypotenuse is always going to be positive. Okay, and these two sides are always going to follow the rules of the grid. Okay, so when you are solving this, some of you might know this right away. What's B? Yes, because it's a Pythagorean triple. Okay, they're not all going to be that simple. This one is. Okay, but you can always solve using the Pythagorean theorem. Just remember, when you take the square root, it's plus or minus. So you are going to use positive or negative depending on where that is on your grid. So in quadrant 3, the x and the y are both negative, so your B is -4. From there, you're going to find your cosine and your tangent of x. So I want you guys to try that. All right, let's check to make sure you did that okay. So your cosine is the adjacent over the hypotenuse, so it's a -4/5. And then your tangent is opposite over adjacent. So a negative over a negative is going to be a positive. Okay, so go ahead and adjust it to positive if needed. So this is opposite over adjacent. This is adjacent over hypotenuse. Okay, so you are going to use these in our next step here. Okay, and then if you wanted, you also have the choice to use method 2, which is using the IDs. Okay, this is also really what some of you did on the preview worksheet when you guys had to find some of those sine and cosines and tangent. You guys use x squared plus y squared equals 1. For this, you could just use the sine squared plus the cosine squared equals 1. So you could use that identity. If you're given the sine, this is the sine squared plus the cosine squared equals 1. What can I substitute in for the sine? Yeah, you can just substitute in that negative 3/5. And then can you guys solve that using your order of operations? Okay, so when you square, you get 9/25, okay, which is going to leave you with 16/25. So you get a common denominator, which would be 25 over 25. That's how we get the 16 over 25. And then we have to square root. So again, when you're doing the square root, it's that plus or minus 4/5. And then you know that x is in quadrant 3. Okay, so you can use the all students take classes to help you figure out what those signs are. Bless you. And then I really would, I would use the triangle once you know what your sine and your cosine are to figure out your tangent. Okay, so now you know you have the -4, -3, and 5. You'd be able to find your tangent from there. All right, so we are going to be using method 1 most of the time. You can choose when you are doing it on your own if you want to use some of those IDs. And now we are going to find the double angles. Okay, so step 2 is going to be finding those double angles. Okay, so to find those, we're just going to substitute the values that we found in step 1. Okay, so this is our double angle for sine. So when we are plugging these in, notice that we found the sine of x. Okay, so the sine of x and the cosine of x, they are fully replaced. Okay, the sine of x is -3/5. the cosine of x is -4/5. Okay, and then we just have to multiply across. If it helps, put it over 1. So then you can just multiply straight across. Negative times a negative is a positive 12. 12 times 2 is 24. In the denominator, 1 times 5 times 5 is 25. So that is going to be the sine of 2x. Okay, so to be successful at these, you do have to remember how to multiply fractions and your order of operations. Okay, now you can use any of the 3 equations to find the cosine of 2x. If you were doing this on a test, I would recommend that you use this one for this particular problem. 1 minus 2 sine squared of x. Anybody tell me why I'd suggest using that for this problem? What's that? No. They're all the formulas. They're all going to be...
Because you were given the sign, so in case cosine is wrong.
Yes. So really just to cover yourself. So you were given this, you know this is right, okay? If you happen to make a mistake with the cosine, it wouldn't even matter. You would still get this question correct, okay? Again, you can use any of them, and you are still going to get the same final answer. And then anytime it's squared, we take that value and we square it. So this is the sine of x squared. So we're going to plug in -3/5. And if you guys want to try another one, you can do that. All right, so if we do order of operations, we have to square first. So you get 9/25. Okay, and then here you have -18/25. I want you to finish that one, and then I want you to use this one for the tangent. And then we're going to use the other one next time, okay? Okay, so I want you to finish the double angle for cosine, and then I want you to do the tangent one. Okay, so Lucas, what'd you get for this one, the cosine of 2x? Yep, 7/25, great. Okay, so this would be 25/25. 25 minus 18 would be 7. All right, and then let's make sure you guys started this one correctly. So you're going to do 2 times, our tangent of x was 3/4. So we're going to plug that in. 1 minus 3/4 squared. Okay, so when you're doing this one, this is like 2/1. So 2 times 3 is 6/4. What does that reduce to? Yep. So 3/2 on the top. Okay, and then here you have 1 minus, if you square this, 9/16. Whenever you have a 1 minus, you're just changing that into 16/16. Okay, so this is going to be 7/16. So when you have a fraction within a fraction, remember, you can think of it like this. 3/2 divided by 7/16. Because then we're just going to keep change flip, right? So we're going to keep the 3/2. We're going to change to multiplication. And then you can multiply across, or I recommend simplifying here. Because what's 16 divided by 2? What's 16 divided by 2? 8. So then you just have 24/7. All right, what do we think of that so far? Not too bad yet? We are going to do it in the next one, and then I'm going to talk about the when you should use which one. And so I want you to have an example of how to do it like this in your notes, okay? All right, and then let's look at part B. So part B, you are again given a trig function, but it doesn't tell you what quadrant it's in. You get to figure that out based on what they give you. It's a mystery right now. So they do tell you that the cosine of theta is greater than 0. So they're just trying to tell you that, hey, your cosine is positive. So your cosine is positive, your tangent is negative. We just have to think of that all students take classes. Okay, which quadrant has a positive cosine but a negative tangent? 4, great. Okay, because everything's positive in quadrant 1. Okay, so theta is in quadrant 4. Okay, why is that important? Because that's where you need to draw your triangle. Whenever you draw your triangle, again, this side is always going to be flush with the x-axis. Remember, this is your x-axis, this is your y, and it's going to follow those rules. Okay, your theta is always here at the origin. And if you have -1/3, remember, that's your opposite over adjacent. So the opposite is 1/3. Hypotenuse is always positive. Oh, sorry, this is opposite over adjacent. It is still going to be positive. But when you're deciding where to put the negative, does the negative go on the x or does it go on the y? The y. It's all based on the position. See how the y is underneath? That's why you're putting it on your y there. Okay, so the negative goes based on the quadrant. Okay, in quadrant 4, you have a negative y and a positive x. All right, so then let's solve for this. We'll call it c for right now. So 3 squared plus -1 squared equals c squared. All right, so then we have 9 plus 1, which is 10. And then we're going to take the square root. Okay, the hypotenuse is always positive. So anytime you do the square root and the plus or minus, this is going to be positive root 10. You only have to worry about the plus or minus if it is the x or the y, and then that's going to follow the quadrant symbol. Okay, so from there, we're going to write out the sine, the cosine, and the tangent. So the sine is the opposite over the hypotenuse, so -1 over root 10. Okay, you can leave it like this because your final answer is going to be simplified. If you want to simplify it here, you can, okay, but you don't have to. You just have to make sure it's simplified at the end. Okay, so your cosine is adjacent over hypotenuse, and then your tangent was given. Okay, so you have the choice. If you want to simplify by rationalizing, you can, and you'd have negative root 10 over 10. Here you'd have 3 root 10 over 10. That would be the same. Okay, you don't have to simplify in this step. You do have to simplify at the end. Okay, whether you plug in the simplified or this original, you are going to get the same solution. Okay, so you can decide where you would like to simplify, okay? All right, so I'm going to use the unsimplified versions because I just want to show you how that's going to work. Okay, so the first thing we're going to do is the double angle for sine. So the double angle for sine is 2 times the sine of x times the cosine of x. Remember, the sine of x and the cosine of x, you are plugging it in for this whole thing. Okay, you're not plugging it in for just x. Okay, so for the sine, if you do -1 over root 10, and for the cosine, if you do 3 over root 10, you are going to get the radicals to cancel. I like to put the 1 under just to remind myself I multiply all the numerators. Okay, so I have 2 times -1 times 3. And then what's root 10 times root 10? 10. Okay, so then you get -3/5. That is the sine of 2 theta. Okay, you don't have to write this part down. I'm just going to show you. If you use the other one, -root 10 over 10, 3 root 10 over 10, okay, what that would give you is you have 2 times 3, which is 6. The negative here, root 10 times root 10 is 10. 100 times 10 times 10 is 100. And then do you see that this is -60 over 100? That would reduce to -3/5. You'd have -6 over 10, which would be -3/5. Okay, so you would get the same thing there. Okay, again for cosine, you have options. You can pick your favorite cosine equation. I'm going to do 2 cosine squared minus 1 just to show you a different equation for this. Okay, and if it's cosine squared, we're going to have to square that, and we're going to have to follow our order of operations. Okay, so the cosine is 3 over root 10. Okay, so why don't you guys see if you can simplify that? And then we are going to use the other equation for tangent now. Alright, so then when you square that, you have 2 times 9/10. 3 squared is 9, root 10 squared is 10, minus 1. You can put this over 1, Okay, you can multiply 18 over 10 and then reduce. Okay, or you can just reduce here. So 2/10 is 1/5. So this would be 9/5 minus 1. Okay, 1 is like 5/5. So you will get 4/5. 9 minus 5 is 4. Okay, you could also leave it as 18 over 10. You get 8/10 reduces to 4/5. That is fine. Okay, however you want to reduce that, that is fine. All right, now, anytime you are asked to find all three, the sine, the cosine, and the tangent of the double angle, your faster method is going to be this, the sine of 2 theta over the cosine of 2 theta. Sometimes you won't be asked to find all three. You might just be asked to find the tangent. And if that's the case, then it's quicker to just use your tangent formula. Okay, but if you are asked to find all three, all you have to do is take your previous answers and divide them. So your cosine of 2 theta was negative 3/5. The cosine of 2 theta was 4/5. And then we just have to keep, change, flip. Okay, so this is going to be negative 3/4. That's the tangent of the double. Again, this does rely on these two steps being correct. Okay, but that is the fastest way if you have to find all three. Okay, if you only have to find the tangent, it's quicker to just use the formula with the tangent. All right, any questions for me on those? So those are all the double angle formulas. Okay, the next thing we're gonna learn about are the half angle formulas, and these are gonna relate the values of the trig functions at 1/2 x, okay, to their values at x, except they don't use x in these formulas. So two of these formulas contain the plus or minus symbol. That's because you are going to have to decide which ones are positive and which ones are negative. Okay, so for sine and cosine, you're going to have to determine if it's plus or minus. Okay, it depends on the quadrant in which the half angle lies, which is that u over 2. Okay, so the sine depends on the quadrant in which that half angle lies. Okay, and again, I just want to specify it depends on where the half angle lies and not the angle. Okay, so it's the half angle, not u. Okay, u over 2 half angle, u the angle. 2u double angle. Okay, so look at these half angle formulas. In order to find the half angle of sine, you have to know the cosine of u. Okay, in order to do the cosine half angle, you have to know the cosine of u. And for tangent, you need to know both the sine and the cosine, no matter which one you choose. Okay, and for tangent, you don't have to worry about figuring out if it's plus or minus. Okay, so when you're using that appropriate half angle to find the exact value, if it is sine or cosine, you're going to find the quadrant that the half angle is in to determine if your solution is positive or negative. And then you're going to find the value of the angle by multiplying by 2. And then you're going to plug that into the formula. Okay, so these are your two steps. If sine or cosine, you're going to find what quadrant the half angle's in to determine if it's positive or negative, and then you're going to find the value of the angle by multiplying by 2. Okay, that's what you're going to plug in. All right, so I'm going to break these down into steps for you. So your first step is to just identify what that half angle is. Okay, the half angle is whatever you are given. So we were given 22.5. So the half angle is 22.5 degrees. 22.5 degrees is in quadrant 1 because it's between 0 and 90. In quadrant 1, this is the cosine. The cosine is positive. Okay, so you are going to choose the plus. Okay, in step 2, you are going to find the angle. Now, really what you're doing here is you are solving. See how this is u divided by 2? So if you want to find u, you just have to multiply both sides by 2. So you do 2 times 22.5. Okay, what is 2 times 22.5? 45 degrees. Okay, now this should be on the unit circle. If it's not on the unit circle, then you didn't do something right. Because sometimes people will just plug in the 22.5 and they'll be like, well, I don't know what that is. Yep, it's because you didn't double it. Okay, so anytime you double it, it should be something that is on the unit circle. Okay? After you do that, now you can plug the value into the formula. So we're going to use your cosine. Okay, so u is 45, so we're going to plug it in here. So this is what I'm looking at. Cosine of u over 2 is 45 over 2. Do you see how if you divided that, now you have the original problem? 45 over 2 is 22.5. But we're just rewriting it because here we have to plug in u. So we already said it's positive, so we're just going to use the positive. And then this is u, not the cosine of u. So you plug in 45 for the u. It's a little bit different than what we were doing before. Okay, so once you have the u, you're going to plug that in. And then the cosine of 45 degrees, don't we know what that is? Yeah. So it's 1 plus root 2 over 2 divided by 2. Okay, now you know how to simplify something like this without me. You've done it many, many times. So let's just work on simplifying the top. So if you have 1 plus, I'm going to just write it here so you guys can see it separately. If you do 1 plus root 2 over 2, how do I simplify that? You got to multiply by 2 over 2, so you have a common denominator. So then what would that end up being? Yep. Okay, so then I'm going to write that down. And if you want, you can put like you're doing times 2 over 2. So you have 2 plus root 2 divided by 2. And then that's still all over 2. I know there's a lot of 2's going on. Okay, we're just going to break it down. We doing okay? All right, so when you're doing this, remember, you don't have to write this part out. I just want to show you. This is 2 plus root 2 over 2 divided by 2, all underneath the square root. So if we have a fraction, we're going to do keep, change, flip. All right, so my next step It's just going to be 2 plus root 2 over 2 times, when you're doing that flip of the 2, you're multiplying by 1/2. Multiply by the reciprocal. Great. All right, so then on the top, you get 2 plus root 2. What do you get on the bottom? 4. 2 times 2 is 4. Sometimes when we're working with 2s, people want to keep it as the 2. Okay, and then we still have the square root. We're going to split it up into the square root of the top over the square root of the bottom. And why would I do that? Yeah, because it's a perfect square. So it'll only be 2 on the bottom. Okay, and I know that seems like a lot right now, but I promise as you practice it, it's going to get easier because we've divided fractions before. It's just combining a bunch of different things together, so that can feel like a lot. All right, so then let's see if we can do the first couple steps with part B. So the first step is just identifying that your half angle is that pi over 8. So you can identify the quadrant. So pi over 8, what quadrant would that be in? Yep, because it's between 0 and pi over 2. Okay, so that means the tangent is positive. Okay, and really, if it's the tangent, you don't have to find the plus or minus. I just want you to practice doing this step. Okay, and then your second step is to double. Okay, so the angle is double pi over 8. Okay, and 2 pi over 8 is going to reduce to pi over 4. Okay, so this is what you're going to end up plugging in to your equation. Now you can decide which tangent equation you're going to use. I'm going to use the first one, which is 1 minus the cosine of u over the sine of u. Okay, and pi over 4 is 45 degrees. So yeah, if we were doing sine or cosine, we would have something very similar to what we had before. This is just a little bit different now. So you have 1 minus the cosine of pi over 4 over the sine of pi over 4. And we know the sine and the cosine are both root 2 over 2. So we have 1 minus root 2 over 2 over root 2 over 2. Again, this is something where if you take it slow and you break it down, this isn't going to be too difficult. The difficult part is being able to just break that down and simplify. Okay, so 1 is 2 over 2. So on the top, I'm going to have 2 minus root 2 divided by 2. And then this is divided by root 2 over 2. So then I can just keep change flip. Okay, so the 2's are going to cancel, but now I have a radical in the denominator. I can't keep that, so I have to rationalize. Okay, so if you rationalize, root 2 times root 2 is 2. And then can you guys distribute to find the numerator for me? So multiply by root 2 each one. And then, yep, Ilaria, will you tell me what you got for that numerator?
2 times, like, square root 2.
Yeah. You said minus.
Oh,
Yep, so it'll be the negative there. And then you can divide both of these by 2. So we're going to do one more step. So those will cancel. You'll have root 2 minus 1, or negative 1 plus root 2.